highest common factor and lowest common multiple. When we're doing these questions, the examiner wants to see you doing the correct method, which involves using product of prime factors. But do remember what these terms actually mean, because that can help keep you right as well. Highest common factor, which is also known as HCF, means the biggest number that divides in to both numbers. So in this case, what is the biggest thing that divides into 36 and 60? You should be able to work that out just with your knowledge of factors without even going through the full method. So for instance, 6 divides into both 36 and 60, you can tell that straight away. But even bigger than that, 12 divides into 36 and 60. So that is going to be the highest common factor. The lowest common multiple, also known as LCM, is the first number that is a multiple of both 36 and 60. So going through, if you wanted to work this out without prime factors, you would go through your times tables of 60 of the bigger number, checking each time whether 36 divides in. So the first one is 60 itself, and 36 does not divide into that. The second one is 120, and again 36 does not divide into that. The third one is 180, and 36 does divide into that. So the lowest common multiple would be 180. You'll note that the highest common factor, although it has the word highest in it, it is always smaller than the two original numbers, smaller or equal to one of them, to the lower one, sorry. Lowest common multiple is always bigger or equal to the bigger of the two numbers. Please make sure that you do not get those terms mixed up. Now, that's how you do it by logic, but when you're doing this in an exam, you should be working through it properly. So what the examiners want to see is you first of all using product of primes. To do the product of primes, starting with 36, we choose the first prime number that divides into 36. Now remember what your prime numbers are. Your prime numbers are 2, 3, 5, 7, 11, 13. The list goes on, but you're unlikely to need larger prime numbers than those ones. So 2 is the first thing that divides in here. So 36 divided by 2 gives me 18. I check if I can still divide by 2. And if so, I do that. So I can. 18 divided by 2 gives me 9. I check if I can still divide by 2 again. I can't this time. 9 isn't divisible by 2. So I check my next prime number, which is now 3. 3 divides in, giving me a 3. And again, I can divide by 3 again, which brings me down to 1. You keep going with this ladder method until you finish with a 1 at the bottom. Doing the same thing for 60, dividing by 2 gives me 30. Divide by 2 again gives me 15. Can't divide by 2, so I try 3, which gives me 5. Can't divide by 3 this time, but I can divide by 5, and that brings me down to 1. Once you've got both numbers split into their product of primes, what we're going to do is write them out as two sets of multiplications, so we can then look for pairs and look for how much each number comes up. So for 36, we have 2 times 2 times 3 times 3. Now, just as a side note here, and we're not going to do it in this case, but if you're doing just a product of primes question and it asks for the answer to be given in index form, you need to remember to give your answer like this. 2 to the power of 2, 2 squared, because there are 2 2's. 3 to the power of 2, because there are 2 3's. With product of primes, remember as well, we do have the word product. Product means multiply. Therefore, it is always a multiplication sign in between the terms. It is never a plus sign. Now in this case, we're not going to actually use the index form, so let's get rid of that. We do the same thing for 60. So 60 equals 2 times 2 times 3 times 5. Now, to get the highest common factor, first of all, what we're going to do is we're going to look for pairs of numbers that appear in both 30 and 60. So, for instance, there is a pair of 2's. There is another pair of 2's. And there is one pair of 3's. So altogether, the pairs that we have here for our highest common factor, we have a 2, another 2, and a 3. So I have not taken 4 2's and 2 3's. I have taken a 1 2 because there is a pair of 2's here, 1 2 from this pair of 2's and 1 3 from this pair of 3's. So we write them in pairs and we take 1 from each pair, and that gives you the highest common factor. The reason I've written the 5 with a bit of a space over here is to help with this, because if you keep all your 2's above each other, all your 3's above each other, it makes it a little bit easier to spot the pairs. To now do the lowest common multiple, for the lowest common multiple, rather than looking for pairs between the two groups, we're looking for the biggest amount of each number that appears. Now if I consider 30 and 60, both of them have 2 2's, so it doesn't matter which one I take. If I consider 30 and 60, 30 has 2 3's, but 60 only has 1. So that's the bigger amount of 3's. And if I consider 5's now, 60 has a 5, but 30 doesn't have any. So 1 5 is the biggest amount of 5's. So I pull those all together, 2 times 2 times 3 times 3 times 5. That is 4 times 9 times 5, which is 180. And we can just compare this with the answers that we got from logic at the start and see that they do match up. Okay, we'll go through this again now with two different numbers, 63 and 60. So step 1, product of primes. 2 does not divide into 63, so I go for 3. 3 goes in 21 times. I can divide by 3 again, which brings me down to 7. And then, as 7 is a prime, it's the only number that's going to divide into that. So that brings me down to 1. For 300, this will be a longer one. Dividing by 2 brings me to 150. Dividing by 2 again brings me to 75. I can now divide by 3 to get 25. And then by 5 to get 5. And finally by 5 to get 1. So writing these out now as our product of primes, just put a little line here to separate this out. So we've got 63 is 3 times 3 times 7. And then we've got 300 is 2 times 2 times 3 times 5 times 5. Now, if I start by looking for my pairs of numbers for highest common factor, I can see 63 doesn't have any 2's, so there's no pairs of 2's. There is one common pair of 3's. There's no pairs of 5's, there's no pairs of 7. So the highest common factor between these two numbers is very simply 3. So if you only get one pair and there's nothing to multiply it with, that pair is the highest common factor. To do the lowest common multiple, we've got 2 2's here That's a bigger amount of 3's because 300 only had 1 3. That's the bigger amount of 5's. And that's the biggest amount of 7's. So I need to include all of these. 2 times 2 times 3 times 3 times 5 times 5 times 7. Now 2 times 2 is 4. 3 times 3 is 9. 5 times 5 is 25. And then timesing by 7 as well. That becomes 36 times 25 times 7, which gives you a final answer of 6,300. So the highest common factor of 63 and 300 is 3. The lowest common multiple is 6,300. And this one demonstrates why the method of the product of primes is so important, because to try and work this one out by logic, you would have been there a very long time.